Welcome to what I hope to be the most comprehensive guide to fan control available on the internet, basically. So, there's a lot to get through, and I'm going to timestamp everything because some of you probably may already actually have the software, and that's why you're watching this video, or some of you may have absolutely no idea how to control the fans on your computer at all. So, I'm sort of trying to accommodate for everybody here because I think it's actually a very important thing that a lot of people they'll set up a computer and basically give this no thought, just let their BIOS automatically control it and their GPU's built-in fan curve automatically deal with it, basically. So to get started, you're obviously gonna need the software itself. So to do that, I will leave all these links in the description, by the way, but at a bare minimum, you're actually just gonna need fan control itself. So you're gonna go to this link here, once again, in the description. You'll click here. And yeah, I've already obviously downloaded all this stuff. It's not big anyway, but I just sort of did it just to speed things up a bit. But yeah, you're going to save that there. And now this is an optional extra. You don't have to do this, but I do recommend having HwInfo anyway. It's another very good piece of software. But if you want to import more sensors, so this one here, it will come with inbuilt things. So you'll be able to do based on usually things that are natively built into your motherboard. So if it has like a VRM or a PCH temp sensor or any other sort of external sensor, it may already be there. It'll also have your CPU core temperatures and your GPU temperature, usually just as a part of the base software. But say you have some other external sensors or whatever that you want, or like say like RAM temperature, for example. Yeah, you're going to need HwInfo because this will show all sensors, and you're going to need this plugin here, which will allow you to import sensors from HwInfo into fan control. So that is going to basically the same thing. Click download here and click release.zip and save this one. And same with HwInfo. You're just going to go here and save that. So now, assuming that you've downloaded all that, you should have these three here. So you're just going to go ahead and extract them all. The extract file's up on my other screen. Doesn't really matter, I suppose. I'm sure you all know how to extract things. If you have 7-zip, you can obviously use that. But I'm just going to assume that you may not. And you're just using the one that's built into Windows, and that's fine for this. They're only small. And we need this one. So yeah, hit extract on it. Alright, so now that you have all of these, if you want this to work so that you can get HwInfo working, you will need to go into this folder called release and copy this stuff here into wherever you put this. So mind you, this doesn't actually have an installer. You could basically just put this anywhere on your computer. I usually just put it under C program files though. But for the case of this tutorial, it's just going to be on my scratch disk here. And you're going to want to put this into plugins, which doesn't actually exist yet. So I guess you actually have to run it first. So let's do that. Alright, here we go. So when you open up the software, you will be obviously greeted with this EULA agreement, all that. Just hit OK on it. Now you can run through this if you want. For the most part, it works just fine. But if not, I'm just going to run you through how to manually set it up. Doing the automatic setup is pretty simple. It just takes time, and you just follow the prompts, and it's really self-explanatory. So I don't really think I need to describe it for you. But on to another point as well. Before you do all of this, you will need to make sure that in your BIOS you've actually set your fans correctly. So each BIOS is going to look slightly different, and depending on whether you actually have PWM or DC fans, so in other words 4-pin PWM or 3-pin DC, this can also just be called voltage mode in some BIOSes call it that. But you're going to want to make sure you set all these up properly, so you're going to have to look at your fans and see how many basically how many wires. Is it a 3-wire or a 4-wire fan? 3-pin or 4-pin header. And also bear in mind that a lot of motherboards do have dummy 4 pins on them, especially older ones. You'll find that only the CPU one, especially if we're talking about like stuff that's like over a decade old, you will find that only the CPU header is actually a PWM header. The other ones are basically a dummy 4 pin. So there's 4 pins there, but that the fourth pin's actually not really connected to anything at all. As I said, it's a dummy header. So just you're gonna have to look up your specific motherboard to see which ones actually are PWM headers if you intend to use something that's PWM with it, be that a water pump or a fan that's PWM. So yeah, here we go on the ASRock BIOS. Use under hardware monitor and make sure the control mode is set to PWM mode. This is the Asus one, which is going to basically be the same for everyone because Asus hasn't changed this thing in like, geez, since like Ivy Bridge, I want to say. I think Sandy Bridge had the older one still. I know they definitely did on X79. I'm not sure about, oh, what is it? What's the standard one called? Z67 or whatever it was for Sandy Bridge. Yeah, anyway, never mind. And just make sure that obviously you set this one to the correct one, either PWM or DC here, and make sure you hit apply on it or it won't actually do it. Sometimes you'll actually have to find you have to just click one of these and just change the slider slightly so that it actually gives you the apply option, because often just clicking this doesn't actually give you the option to apply it, which is dumb, and Asus should fix that. On EVGA, you want to make sure this is set to smart here and PWM here. Although it doesn't really matter as long as this is set to smart, usually it'll work, but just to guarantee it does, make sure this is set to PWM here. Basically, all that's really doing is when you set it to PWM here is setting it to the curve that you set under smart fan settings. Gigabyte. So Gigabyte has like a couple of different ones on their modern ones. So yours may look like this. And once again, you'll just need to make sure that this is set to PWM for each individual fan. Okay, I actually wanted the other one next, but anyway, I guess this doesn't matter. So this is like if you have like an older like Z77 or something like that, you're going to want to make sure that the fan control mode for the thing that you intend to control is set to voltage or PWM, depending once again on what your needs are there. If you keep scrolling down, you'll find that it will have the ones for the system fan as well. So yeah, just keep that in mind that you need to set it for every single header that you actually want it on. This is the other Gigabyte one. This is probably the more common one that I see anyway. It's here, CPU underscore fan control mode, which is actually just named based on what it's called over here. So you'll have to go through this list here and set these to, once again, either PWM or voltage mode. I believe in this one it's called voltage once again, not DC, because that's like a Gigabyte thing. Here we have, what is this, MSI? Yes, definitely MSI. And over here you've just got, you just click which one you want it to be. Obviously, you can obviously just set these to auto and the BIOS should figure it out, but just to guarantee everything works properly as you want it to, just set it manually. So here we go, getting into if you have older blue and gray screen stuff. This can either be usually called CPU Q fan control, or it could be called smart fan control, or it'll be something along those lines, and it will be under like PC health status, or in this case hardware monitor, depending on once again which BIOS it is, but usually it's called one of those two things. And you want to make sure that is the Q fan control or smart fan control is set to enable basically. And you can see here, this one also has its chassis fan, so you know that the chassis fan on this particular board here would be a proper 4-pin PWM. Once again, here we've got an example of another older BIOS, and you see this one here. Actually, you can set the mode. So once again, same as the other ones. It's just the text version of it. I guess you don't get as much. You don't get a fancy picture to look at basically, but the functionality is exactly the same. And here I believe this is the X58 BIOS here. Actually, I have tagged it up here. And this one here looks like, but yeah, anyway, you can see here this one has a PWM fan 4-pin, and smart fan is the control type that you want. And I believe that's all the pictures I had. Yes. So with that out of the way though, so make sure you've got this set properly in your BIOS. If you don't set this properly, it may not work. You know, your mileage may vary on that one. But anyway, yes. So back to the software. So you'll see here when you open it up anyway that nothing is set, and you'll be greeted with this, and you're gonna have to figure out, I guess, now which fans are which. Obviously, the graphics card, that was an easy one because it's already listed, and you can rename these. So if you click in this box here, I can write like GPU, or you can call it you can call this whatever you want, GPU fans, whatever. It doesn't matter. And now, if you actually want to verify that, what you can do is you can click here to take control of it, and then click over here on the 3 dots and click manual control. And you'll see now it's actually increasing, and you'll be able to hear, well, you won't be able to hear, but I can hear the fans getting ramped up, and I can also see the speed reading heading up here. So now, once you've actually verified that, yes, that is the one you want to click pair speed sensor, and then click on the one that you want to pair it to. And now you actually get this reported here. And you're going to have to go ahead and do that for pretty much all of them. So fan 4, I know this on mine. This is my exhaust fan. The same here. I already know this because well, it's my machine, and I've set this up on here before. I'm just really redoing it again for the sake of the tutorial. This one here is the pump. Fan 2 is the radiator fans. And you know, you can yeah, I've already done that there. Pump. So the other ones that aren't in use, you can actually click here and you can hide them away, because you know, you don't need to clutter up anything with you know, with stuff that you're not using anyway. So with these ones here, I'm also going to go ahead and hide them. And now what you can do here is you can go here and you can click here. Let's just make this a big screen now. So yeah, now you've got it set up like that, it's nice and neat. Also, yes, you can choose columns if you want it like that. I just usually leave it like that, but that's up to you. That's a personal choice. And you can also choose to hide fan speed cards, which gets rid of these because the once we actually pair them all. So we'll go pair, we'll go pump, exhaust fan, pair, and here, pair. Oh yeah, silence. That's so much better. I can hear everything getting turned down. That was the radiator fans I was doing right. Yes. Okay. Now what you can actually do is go. You can hide them away because you can see the RPMs already written here. So what you can also do here as well is so once again, we want to take control of all of them. So if you untick this, this goes back to the default. So whatever you've set in your BIOS for something like this, and for the GPU, whatever is the default GPU curve, basically. Yeah, so here you can set the step up and step down. So this is basically how aggressively it's going to ramp up. So if I click manual control here, you notice if I drop them down, see how it goes in 8% increments stepping down, and it's going to be the exact same on the way back up. So you can make these basically less aggressive if you want. Offset is exactly what you think it does. Basically just offsets the percentage. So in this case by 3%. Not really sure what your purpose of doing so would be, but you can. The minimum percent sets basically a hard limit at how low it can go. So if I set this to say 30%, and even if I choose to set this to 4 here, and later on when we automate it, you notice it won't go any lower than 30. Like that's it. So you can set that if you choose. If not, you can just leave it on 0. It depends if you want fan stop functionality or not. Now, not all fans can do this. You'll have to actually check the data sheet of the specific type of fan that you're using. And basically, if you look at the PWM chart on it, you will see at the bottom if it allows 0 RPM at a 0% PWM signal. Or if the RPM range on the fan says, say, like 0 to 1600 RPM, for example. If it says it's like 500 to 1600, then good chance it can't do fan stop. Another good sign is obviously if the manufacturer just advertises straight up that it has fan stop, then you know for sure it definitely does it. Because, you know, sometimes there might be certain fans you may not need them always running. You know, that's not always needed. So that might be when you're choosing your fans, just something to look out for. Start and stop is pretty much, yeah, if you're going to set up fan stop on it. You can set a limit where basically under it, it will just stop the fans. Basically, it'll go to 0%. So if I set this to like, you have to set this one higher first, but that's basically when this goes under this value here, it'll just stop the fans no matter what. And the start value, you can set this higher like this because say you have a set of fans that they'll run happily at like say 20%, but they won't actually get going unless you give it 30%. So basically what that will do is if I turn this down now, you'll see as soon as it hit 20, see how it drops straight to 0. Now when I do this, see it bumps to, oh hang on, I did that wrong. We'll set it to say, if we go to, if I release it like 23, see how it jumps to 30 immediately to give it that extra bump to get the fan spinning, basically. That's what that's for. I'm just going to turn that up a little bit because I need that because I'm recording. I don't really want my computer to overheat while I'm doing this. So I guess we'll move on to configuring sensors next. So that plugin that was allowing HwInfo to work, let's get that going. So now, actually, I'm just going to close out of fan control software. So now in here, yes, we now have the plugins folder because I guess it's sort of like, if you want to call it, installed it. So what you'll need to do is come into here and copy this stuff. Oops. Into wherever you've placed this folder here and under plugins, just paste this in here. And you need to right click on all of this, by the way, and you'll need to hit unblock on all of it. I'm not sure. I actually think you actually only need the DLLs, but I'm just going to put it all in here because I just know for sure it works. This is how I've always done it. I've not actually bothered to experiment because honestly it doesn't matter. And you notice now the pop-up's gone. So, yep. That's that sorted. So now you're actually going to need HwInfo set up for one, otherwise it's not going to work. So when we open that up, you'll be greeted with this screen here. So you can obviously do a fair few things with HwInfo, but for the most part, we're just going to want the sensors. So we're going to go into here. We'll untick this one. Tick show sensors on startup. Minimize main window on startup. Minimize sensors on startup. And minimize sensors instead of closing. So that's if you open it up and you want to take a look in here and you hit the X on it, it won't actually close out of HwInfo. It'll just put it back in your taskbar, basically. You can auto start. And I turn off automatic update because it's annoying every time it tells you that there's an update, basically. I just find that stuff irritating. But that's like a personal thing that you can choose if you want. Nothing else in here needs to be set. That should be it. And make sure remember preferences is ticked, obviously. Alright, so now that you'll get obviously a config file here. And we can start it up for now. But next time you start this, it will only load the sensors. So now let's pull this over to the screen. You will get this screen here. This is the sensor screen, so you can see, well, absolutely everything about your computer, basically. All of these stats here can be imported into a lot of different things. HwInfo is very universal like that. So we're going to go into, yes, configure sensors. So in here, you can change the polling rate, but I usually just leave it at default. That is completely fine. But what you're going to need to do, though, is go into this HwInfo gadget here. And fortunately, it is already ticked, enable reporting to gadget. Now, the ones that you want to actually be reported, so obviously CPU usage and stuff, aren't going to be that relevant. So let's find something like our VRM temperatures isn't native in fan control. So we're going to want to find that. Yeah, so like here, VR loop 1. We can click here, enable value in gadget. So everything that you want to be imported over to fan control software, basically you're going to need to. So we could even do like that, the drive temperature, why not? Let's just grab a couple of things. So now that you've done that, you can now open back up fan control. And you can hide this in the future as well if you don't want that to pop up. And another thing you can do here is setup, and I usually click start minimize. So basically, you won't notice this booting up at startup. It'll just do its thing at Windows startup, basically. And as you can see here, we now have this load of plugins here, and we've got the temperatures that we asked to be imported, basically. They're all here. And so we can edit our sources here. So I usually find these don't tend to actually do as they say. Basically, the ones that are already ticked are pretty much the ones that are going to work. Yeah, obviously this is the one we imported here, so that's all good. And you can nickname different sensors too. So like if you want, like some of this that's quite a big name. We can basically just write, I don't know, let's just call it SSD. So I'm just going to delete this one because we don't need it. So now you've pretty much got everything set up how you need it. All you need now is to actually configure how you want your fans to be controlled. So for that, I'm just going to full screen this. You can come over to this plus button here. And yes, it has like an auto and a sync option. I've never actually really used this one. This is basically where like the AI already basically creates one for you pretty much. Flat, I am not really sure why you would need this. It's basically exactly as it says. It just sets a flat fan speed. But you can just come over here and as you saw me do before, oh whoops, it was already on that. You can just set it anyway, if that's what you want manual control. The other type would be a trigger. So a trigger is basically exactly as it says. So say we put a little SSD that we've got there. And say we had a fan. This is a SATA SSD. I don't know why you would have a fan on it, but maybe you do. So say you wanted the fan to come on and like if it reaches say 50C, you could go something like this. So there'll be no fan on, and it'll go on at 60% fan speed when it hits 50 basically. That's basically what that does. So, didn't really need to delete it. But anyway, yeah, you'll find that one, that still has like some uses. Like maybe if you have like RAM fans or something like that and you don't want them always to be on, you could set a trigger up so they just come on. But as you'll see later on, that basically the two main ones you're going to use are just graph and mix, which I'll just cover linear really quickly because that's... I'll put a graph here as well. Linear, I don't really find that useful either because it's basically just interpolates between these two temperatures and these 2 points. So it's no different to me just setting 2 points in a graph like this. So for example, a minimum temperature 35 and it'll be at 50%. Look, it doesn't have to be. I'm not going to sit there and line up. You can type it in here, obviously. Max temperature 70 and 80%. So basically, it's no different to me just doing that. So you can pretty much just use the graphs to set your curves for most things. Like this isn't really needed. And mix, we'll get into that one in a second because that's kind of a unique one, and we'll get rid of that. So first up, to set your graph, obviously you're going to want to set what you want to base that temperature on. So say we go core max. So this is going to read off of our hottest core. And we can call this something like CPU. And now this is going to depend, if you have like water cooling or if it's air cooled, for this one here, if you're on an air cooler, you probably just want to control the actual fan that's inside your air cooler, the one that's attached to it. Jeez, I don't know why I was struggling with that so much. But yeah, you're probably just going to want to control that. But say you have water cooling, you may want to control your pump and your radiators based on this. So what you can do is we'll call it pump radiator fans or something like, CPU radiator fans. And so we can go something like this. You can get more than 2 dots as well. So say, and you can set this, depending on, whether you want to gear this more towards being very quiet or if you want it to be more aggressive with the fans. That's you can really play with this. You can set different curves. So you could have it be very, you could have it be very gentle with the fans up until it starts getting hot, and then ramp it in very aggressively at the end. Or you could choose to have, I'm just sort of like just eyeballing it here, but yeah, you could choose to have something a bit more standardized like that. And also you can choose the minimum temperature on the graph and the maximum. So this does only actually go down to 80 unless they've updated that. But I'm pretty sure, whoops. Oh, it's not even like me. Oh. Can I not? I'm pretty sure. Wow. Okay. In the older version of it, this actually went down to 80. Now it only goes down to 101. Interesting. Okay, never mind. That's odd. Okay, because I used to like the way the graph was at 80. Because basically when it was over 80, like anything above that is just going to... It's just going to read off the last data point, basically. So if you've already maxed out at like 80 or something, that's... you've already got it at full. Anyway, never mind. So here we've got... like once you've set this how you want it, you probably want to set this up too at the same time, because how you set this up might influence how you set this curve. But basically the hysteresis, as you see in the tooltip here, it is the difference of how much temperature has to increase or decrease before a change is to be actually read. So this helps to like smoothen it out. So if you set this to 1, it means it's going to have a change every 1 degrees basically. Whereas say if I set this to like 5C, it would have to either go up or down 5C within this time. So you can change the response time. In that time period before it actually makes an adjustment. So basically what it's doing is it will just, say it only goes up 1C, it'll just ignore it. And what that's really to do is to stop the fans from going up and down, up and down, up and down constantly. It's so that you have a more consistent speed, which is going to be make it less noticeable for your ears anyway, basically. So under advanced hysteresis, yes, we can tick. This one's already ticked by default, which is good. Ignore hysteresis at minimum and maximum temperatures. So if you have a really high hysteresis set or something and it hits, like 80C or whatever, it'll just ignore the hysteresis and go to whatever that highest point was. And hysteresis only applies on the way down. This is probably, if you're more performance orientated as opposed to silence orientated, that's basically just going to mean that if it increases 1C or whatever, it'll go to the next point, but it won't come back down unless it's reduced. Or in this case, if we set it to 10, it would have to reduce by 10C for it to go to that next point. So how you choose to set this up is completely up to you. And we can do the same for You can do the same for a GPU. I'm not going to actually sit here in the tutorial and set every single one up here, but let's just call this. And so this, it doesn't matter, you know, you can have this, this is really good for a water cooling system, because what you can do here, and that's what I was going to get to here, so if we go radiator fans, let's just call it that. So if we have our mix here, radiator fans, what we can do is we can now take both of those graphs that we've made and we can put them in. And then we can set this to radiator fans. And this function here changes how this behaves. But basically when it's set to max, which is usually how I run it, it will take whichever the hottest one is, or which one's going to ramp up the fans more, basically. I'm not really sure. What's a good way to describe that? Well, right now you see how GPU radiator fans is lit up, and it's asking for 46.7%, whereas the CPU is only asking for 31.5. It's going to take the higher of those two values and apply it to our actual fans. And the reason you want to do this, because this is a very, very common scenario, especially in gaming, is your CPU might not really be working that hard. And most of the time, your fans are controlled based on CPU temperature. But if you have a GPU in the same loop as your CPU, you will find that your water temperatures could be getting kind of hot because your fans aren't being ramped up because the CPU isn't hot. But your GPU is absolutely getting hammered. And so, you know, it's pumping a lot of heat into the loop, and now your fans aren't kicking on because your CPU isn't doing enough to make the fans want to kick on. So with this, you know, basically you can set that curve based on what the GPU is doing. Now, obviously, if you have a air-cooled GPU, like obviously you wouldn't set it like this. You would set this as an individual thing and just go over to here and go, well, we wouldn't call it radiator fans, but just GPU fans, I guess. And you can have that by itself. And you can add as many curves as you want into this to control a specific thing. And then what I would do is, once again, if this was a water cooling setup, which the CPU is, the GPU currently isn't. This is only a temporary GPU in here for now. Graph. So we'll put a couple more graphs in, and I will go like CPU pump and GPU pump, and then set the temperature source once again to go like that. And then I would set a mix and call it pump. And then you can add both of those in, and then you can control the pump. So whatever you call this is what it's going to be called here, basically. So you can set it to this this mix graph here. So this is probably how most people are going to set up something like that. So I'm going to move on to these here. These are a little bit more advanced. So with file, that is if you have a sensor that outputs to a text file. So I should have actually made an example, but that would have been useful. I will just quickly do that now, I think. What I actually can do, we'll just call this, we'll just make a file. And then I'm just going to go into fan control. Yeah, I'll put it up on the screen, that would help. Configurations is where it's saved it. Yeah, the example sensor we've made here. So we can edit this and say I type like 70 into it. Save. Yeah, see now it reads as 70. So if you have like another program or something, or another sensor that can output to a text file, basically you could just read from that. That's all that is. Most people probably aren't going to use that, especially if you have that HwInfo plugin that I have showed you how to set up now. You shouldn't have a problem with that. Offset, once again, that's also that's just calibration stuff. So say like you know for sure, like you've measured this manually or whatever, and you know that it's like 2C out or whatever, you can do that, and now you see it will read 2C higher. Oh, you can also, yeah, you can do that as well. Proportional offset, so that just changes it to percentage based, the percentage offset. So if you know it's like 2% out, because you know when it's a percentage out, you know it's going to be proportional to this temperature as it's cooled. So the offset will get greater as temperature increases. So that's just a way of fixing that. Now here's the two that I find actually useful out of these four here. Time average. So this is like a way of smoothing out if you have very bursty sort of workloads, I guess. So what you can do is you can take like that, and you know you can say I want to average it out over 20 seconds. So if you have a sort of workload where it goes under load for a few seconds, then goes back to idle, then goes back under load, and you find this temperature's fluctuating a lot, and it's causing your fans to ramp up and down, and the you know the hysteresis and response time isn't enough control for you, you can do this. And yeah, as you know, my temperature is sort of staying around the same, so our average isn't that far off. But say I was to put this under load more, you know, you would find that it would take time for this to actually start increasing. And if you want to actually make it read off of this, you would need to go to the time average one. So if we call this like GPU average or something, oh, this was a CPU, but whatever, it doesn't matter what we call it, and we go there. So that's how you would run that one. Very useful for, like I said, for smoothing it out. Now mix pretty much has one major use case in water cooling, especially, and some of you may want to do a fan control strategy where you control the radiator fans based on the delta T of the coolant versus the ambient air. So what I mean by that is you could have, and you would need a motherboard that has external temp sensors for this, by the way. So let's just add, so I don't actually have that set up on this motherboard, but let's just say that there is our coolant temperature, and that one there is, say, the intake air temperature. So if we do that, and then we click subtract on it, that would give us a delta T of 7C. And so from that, once again, you could come over to here to your radiator fans, and you could set a curve base, and this was much better when you could set this maximum a lot lower. And I'm pretty sure even in older versions, again, you could even go lower than 80. So I may actually download an older version of the program or have a look through the actual code and see if we can actually make this go a lot lower, so you have more resolution in the graph, basically, for doing things like this. But yeah, this is definitely a way of doing it, because, you know, in a water cooling system, your coolant temperature is important, and you don't want to just look at coolant temperature because the ambient air temperature around you could vary. So by doing this, you've got something that will work in all sort of environments, I guess. That's one way to sort of look at that. I mean, 7C delta T is pretty good. Obviously, that's not actually a real reading there. But yeah, if you were setting this up, something like that, you probably want your fans to be like, probably, you know, close to maxing out at like, well, definitely no, maxing out at like 15. You want to sort of try and target around like 10. 5 to 10 is like optimal. Just if you want some recommendations there. Now, is there anything else that I actually haven't covered? Not really. Oh, no, I did cover this, the how to change the step downs and all that. Obviously, yes, in here you can change the colors or whatever. You know, it just does like that. I mean, I don't really think that's really that useful. Also, yeah, this delay here. So depending on how quickly, the default is 30 seconds, which usually just doesn't have an issue, but you can make it a bit faster. Just make sure that, say like HwInfo loads before this does, otherwise this will throw an error and you'll have issues. So while editing this, I realized that I missed out on actually quite a major thing, and that is that you can save profiles here. So what you can do is you save the configuration, that's what the default one's called, and you can create other ones too. So you can have, like, say, like a silent profile, and then I could change all this again and go save as to make a completely different one, and we can call it, like, performance or something like that. And then what you can do is you can load configuration, so you can choose which one here, or let me just bring the taskbar across. You can actually right click here and go configurations, and you can select. So depending on what you're doing, you might actually want to change your fan curves, but usually I don't really bother with this because, like, I usually just set it up so it works in all scenarios anyway, and that's kind of the whole point of it. But yeah, do make sure after you make any changes to hit save on it, otherwise you'll restart your computer and find that none of the settings you just changed will be applied anymore, and they'll be discarded. Usually when you do hit restart, it does give you a warning about it, but let's be honest, most of us just hit freaking shut down anyway and ignore all those prompts, so, well, at least that's what I do. So if you stuck around this long, I've got a few examples for you here, or that we use the timestamp to skip over to here. But this is just a couple of examples of what a setup could look like when you're finished. Maybe give you some ideas of what you might want to do with your own system. So ignore these graphs here, like those ones there are actually just straight up the default curve, and those ones are just things I think I was messing around with before. Because it doesn't really matter what I enter here, you can't copy and paste this because your fans are going to behave differently in relation to what sort of RPMs they'll do in relation to the PWM value. So yeah, no, you can't copy mine, and what you really want to do for that is just use manual control and just mess around with the slider and just listen to the fans at varying RPMs and see at what sort of point where it's pushing enough air and it's quiet, you find a good middle ground there, or what you think is acceptable. But so this here is an example of what an air-cooled setup could look like. So obviously I don't actually have this exact setup, that's why I've just basically just punched in whatever. But obviously here we've got our pretend CPU heatsink, the GPU, well, the CPU cooler and the GPU cooler. The chassis fans and a RAM fan if you have one. And if you're into memory overclocking, this is or you want to get into it, this is definitely something you're going to want to have. So for the curves, we've got one for the CPU cooler, which I am time averaging, which definitely on air cooling you really want to do this because CPU temperatures especially will fluctuate around a lot. Like, my CPU is sort of under pretty consistent load at the moment. Mind you, this is mine's under water cooling anyway, and it's de-leaded, but you'll find this will flick around quite a lot, and that's going to cause your fans to want to change a lot, even if you do increase the response time. I find just having this just makes it a lot more stable, so you're not listening to it ramp up and down constantly. It's going to, like I said before earlier, it will produce a smoother curve. And the same with a GPU if it's under air as well. If it's underwater, you really don't need to time average it because GPUs, when you water cool them, they're direct die. They tend not to move around in temperature a lot. They're very, very consistent. And actually, to be fair, when you direct die cool a CPU, like my gaming PC, that's direct die, that doesn't really move around a lot either. It sort of behaves kind of like this, but not to the same degree because the GPU die is a lot larger and a lot easier to cool than a CPU die is. If you're wondering why that is and why CPU temperatures overall are just much hotter than GPUs, despite GPUs pulling well, depends on what CPU and what GPU, but usually a GPU will pull more power, thus produce more heat than a CPU will. And then we've got set up for our chassis fans. And once again, I'm using the temperature source as this time average, and same for the GPU. And then for the system temperature, you could also include this. So if there was something in the system that gets kind of warm, maybe you could go off the motherboard temperature or the like the PCH temperature, like the chipset temperature or something like that. if you wanted to include that, or if you had something specific, you could always add that in, and you just throw it all into the mix here. And remember, whatever curves you set here, it will, because we've set the function to max, it will work off the highest value written here. And then we've got this boost one here. I decided to throw this in just to show you that you can actually just do this. So I've got this trigger here. And so when the sum of both the GPU and the CPU exceed 150C, it will kick the fans, well, for 10 seconds, it has to do it for 10 seconds. It will kick the fans onto 100%. So you could have that set up so maybe you don't have to change your... you wouldn't have to change profiles if you wanted to do some benchmarking or something like that. You just wanted the fans to kick all the way on. That's something you could add in. That's always an option. And same for the RAM fans. I sort of just, you could set this on a graph too, but most of the time it's like you don't need it to necessarily ramp up with temperature. You just need them to be on, and maybe you don't want them on all the time. So you could do something like this, where you've got a trigger, so at 40C they'll kick on, and at 30C they'll kick back off. Alright, so let's load my example for water cooling. So it's more or less the same thing. The only real difference here is obviously we have a pump involved with it. And if you have two pumps, you could definitely control them individually. If you're running them in parallel, you want them to be exactly the same, because you don't want one pump to spin faster than the other, because you'll backflow the other pump and potentially stop it. But if you're running them in series, you could even potentially, like at lower speed, you could just switch one pump off, save yourself some power and save some noise. That's an option for you. But usually you would run two pumps so that you could just generally run the pump slower if you have a very restrictive system. Otherwise, you don't really need two pumps. And radiators. So for this one, yeah, if you do happen to have your intake radiator and exhaust radiator, or you have multiple radiators, you could have them on separate headers off your motherboard. Do bear in mind you don't want to daisy chain too many things off the header, but I always run a hub of sorts. So basically it has its own, it has 12-volt power coming off of the power supply, not from the motherboard header. I only usually have the tac sense and the PWM signal coming off the motherboard, so I don't have to worry about burning out motherboard headers anyway. But once again, that depends on what fans you're running, and you'll have to check how many amps it says on it'll usually say on the actual hub of your fan. And most motherboard headers are rated for 1 amp, so you don't want to be exceeding that, otherwise you will potentially bust your motherboard, and you probably don't want that. But what you could do if you did have these on separate controllers, so you could control them individually, is you could set up another curve here. So if you wanted like a positive pressure bias in your case for dust management or whatever, you could have it so that the intake radiators are always spinning a little bit faster than the exhaust. Or if you had more exhaust fans but you still wanted front bias, you could have the intake spin faster to compensate for that, etc. There's definitely ways you can sort that one out. And obviously here, I've just set some values in there. Usually around 4% per second is usually about like what I kind of just use as a default. But it depends if you want them to aggressively ramp up or not. Once again, that's going to be something you can choose and play around with. As you can see down here, I didn't time average the GPU because I said before there's not really any need to. And I do have this boost function here. So when these are... where did I put it? Here. So when these exceed a certain temperature, I mean, all these values are just, they're all just there for argument's sake. They're not necessarily values you should copy. Like, you're going to have to play around with your own system and see what it likes, basically. But, yeah, you could have the fans kick on to 100% to keep the liquid temperature down. And also, as I said before, I didn't make an example for it, but you could, because I basically already did it in the other segment of the tutorial, that you could base it off of off the off the ambient temperature versus the liquid temperature, so the delta T. You could definitely do that, and you could technically do that with other things too. So if you had other temperature sensors, you could do that with air cooling too, to control your case fans as well, to monitor the air as it before it comes into the case versus the air inside the case. You could set up control like that, but I don't really think that's necessary. It's more something I would only really do for water cooling, and even then, I find just a normal strategy like this will probably work just well. Not probably, it just does just work just fine. And obviously, if you want a lower delta T, you would just set a more aggressive profile with these graphs, and you would achieve that anyway. But yeah, I just thought I would give a couple of examples of what's actually possible with this. And if you do set it up like this, you'll find you won't really be hearing your fans fluctuating around in RPM a lot. They will stay quite consistent based on the kind of workload that you're doing. So yeah, but yeah, I think that just about concludes everything as far as setting anything up. If I can think of anything else, I'll throw it in there. But for now, I think you should be good. If you have any questions, just feel free to leave it in the comments. I'm happy to answer it for you. But I think you should be good to go with something like that. Enjoy setting up your computer and messing around with your fan curves.